In section 7.5, I'm going to show you how to use the quadratic formula to solve quadratic equations. Now in the last section, 7.4, we went over how to complete the square to solve quadratic equations, and that's actually the process that's used to derive the quadratic formula. So I'm going to go through the process of completing the square on this general quadratic equation. In other words, we're just going to use the process of completing the square on ax squared plus bx plus c equals 0, where a, b, and c could be any numbers. Now, remember that completing the square only works when the coefficient in front of this x squared is a 1. So we'd have to start by dividing everything by whatever that number is. So we'll divide everything by a on both sides of the equation. And that would give us x squared plus b over a times x. And then I'm going to subtract this c over a from both sides of the equation because that's the constant term, and we need to have that on the right-hand side of the equation. So that would be negative c over a. Now this is the step where we complete the square. So we have to figure out what we're going to add. So remember the process is we take this middle coefficient, b over a, we take 1/2 of that, which is the same as multiplying it times 1/2. So we'd have 1/2 times b over a, which is going to end up being b over 2a, and then we have to square that. And if you square the top and bottom of that, you get b squared over 4a squared. And so that's what you'd have to add to both sides of the equation. So we'll say plus b squared over 4a squared on the left side, and then plus b squared over 4a squared on the right side. Now that we've done that, this trinomial on the left side of the equation is a perfect square trinomial, and that will factor down into the square of x plus b over 2a, quantity squared. And on the right side of the equation, I'm just going to get a common denominator. So I'll multiply the first fraction by 4a in the numerator and denominator. So if I do that, right up here I'm going to multiply the top and the bottom of this first fraction by 4a. So that would be 4ac over 4a squared. So when I subtract that, I would get a negative 4ac plus b squared over 4a squared. So I just got a common denominator and combined those two fractions together. Now we're ready to take the square root on both sides. So when we take the square root of the left side, we just get x plus b over 2a. And then on the right side, we get plus or minus the square root of that whole fraction. Now I'm going to rewrite negative 4ac plus b squared by putting the positive thing first, b squared, and then minus 4ac. And then that's still over 4a squared. Now at this point, we can take the square root of the numerator and divide it by the square root of the denominator on the right side of the equation. So we'd have the square root of b squared minus 4ac over the square root of 4a squared. And the square root of 4a squared, this denominator here, is just 2a, because 2a times another 2a equals 4a squared. So that simplifies down to x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 2a. And then we'll just subtract b over 2a from both sides of the equation because we're trying to get x alone on the left and it's being added, so we'll do the opposite and subtract. So x would equal negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And if we wanted to, we could combine that all into one fraction because they have a common denominator. They both have 2a, and you're either adding or subtracting, so you can put that into one fraction. And so you would have negative b plus or minus the square root of b squared minus 4ac, and then that whole thing would be over 2a. Now this final answer that we end up with right here, we'll put a box around it, is called the quadratic formula. So the quadratic formula gives you the answer you're going to get for x after you go through and do the process of completing the square. And the nice thing about that is it will save us from having to go through that process of completing the square each time, because the quadratic formula gives us the end result of that process. So let me give you an example to show you what I mean. Let's say we started out with the equation w squared plus 2w minus 5 equals 0. So that's a quadratic equation. And since the left side of the equation doesn't factor into anything, we'd either have to use the completing of the square process or the quadratic formula. Now we could go through and complete the square on this whole expression, which would require us to add 5 to both sides and then take half of the 2 and square it and add it to both sides and then factor into the square of the binomial and go through the entire process. But the quadratic formula, this formula right up here, tells us what we're going to end up with if we do that whole process. So it would be faster just to use the quadratic formula. Now here's how we use the quadratic formula. We start by figuring out what the a, b, and the c are. So the a is the coefficient in front of the squared term right here. Now that's a 1 because there isn't any number there. So a would be 1 in this case. And it's implied to be 1 if there's nothing else written down. The b is the coefficient in front of the middle term, so that would be positive 2. So b equals 2. And c is this constant term here. In this case, it's negative 5. So that's pretty easy to determine. Just make sure when you do that step you have a 0 on one side of your equation. So if you didn't have a 0, you'd start by getting a 0 on one side and then determine the a, b, and the c. Now once we have the a, b, and the c, we'll just plug those into the quadratic formula. So our answers for w in this case are going to be negative b. Now this negative b really means the opposite of b. The reason I say that is because if b starts out as a negative number, then when you take the negative of it, or the opposite of it, you actually end up with a positive number. But in our case, that's not happening here. b is just the number 2, so we'd have negative 2. So negative 2 plus or minus the square root, and then we're going to take b squared, so 2 squared, minus 4 times a times c. So 4 times 1 times negative 5. And we'll divide the whole entire thing by 2 times a, which would be 2 times 1. Now at this point we want to simplify what's under the square root. So negative 2 plus or minus the square root of, now 2 squared would be 4. And then over here you're going to have a negative 4 times 1, which would be negative 4 times a negative 5. So it would be plus 20. So what you have really underneath the square root is a 4 plus 20. Be careful with your sign here. If you have a negative times another negative, it cancels out and gives a positive. And then in the denominator we just have 2 times 1, so 2. And so if I continue to simplify this, I have w equals negative 2 plus or minus the square root of 24 over 2. And usually we want to try to simplify even further. If this square root, if the number under that is divisible by a perfect square, and this one is because 4 goes in evenly into 24, so we could break that down into the square root of 4 times the square root of 6. And if you did that, square root of 4 is just 2, so it would be 2 times square root of 6. So that's what we're going to do we're always going to simplify that square root if the number underneath it is divisible by a perfect square. If it's not, then there's nothing you can really do. So in this case, we'll have negative 2 plus or minus 2 square root of 6 all over 2. And you can then even go farther with that, because you can kind of do a three-way cancellation here. This number in front of the plus or minus and the number in front of the square root, that's assuming you could pull something out of that, and the number in the denominator. If all three of those numbers can be divided by the same number, you can do that. So in this case, we could divide them all by 2. Now, if they don't all three divide by the same number, then you can't really simplify this answer any farther, and you just leave it. So we'd get negative 1 plus or minus the square root of 6 over 1. And, of course, over 1 doesn't change anything, so I'm not even going to write it down. And so those would be my solutions. Now, if I had used the completing the square process to do this problem, I would have gotten the same answer, but it would have been a little bit longer. And so the quadratic formula is bringing me right to the final answer, and the only work I really need to do is just to simplify that answer down. Okay, let's try another example. Let's say we started out with the equation negative 4x squared plus 7x equals negative 2. Now our first step would be to get a 0 on one side of the equation, so we'll add 2 to both sides. And that will give us negative 4x squared plus 7x plus 2 equals 0. Now at this point, we can determine what our a, b, and c are. So a is the coefficient in front of x squared, so that's negative 4. B is the coefficient in front of the x, so that's 7. And c is the constant term, so positive 2. So we'll substitute those values into our quadratic formula. So we have x equals negative b, so negative 7, plus or minus the square root of b squared, so 7 squared, that'd be 49, minus 4 times a, which is negative 4, times c, which is 2. And that's all over 2 times a, so 2 times negative 4. So now we just want to simplify this down. We want to figure out what number do we really have under that square root. And be careful with your signs again. So when you do this multiplication, you really have negative 4 times another negative 4. That's a positive 16 times 2, so positive 32. So that's really 49 plus 32. And this whole thing is over negative 8. So if we continue to simplify this, we'll have x equals negative 7 plus or minus the square root of 81 divided by negative 8. Now the square root of 81 is just 9. And that'll happen sometimes where the square root comes out to be a whole number. In fact, keep in mind, when that does happen, it means you could have factored this. If you go back over to where we were right here, that trinomial could have been factored. So whenever that square root comes out to be a whole number like that, it's telling you you could have actually factored this and not had to use the quadratic formula. But the quadratic formula still will work. So we'll have x equals negative 7 plus or minus 9 divided by negative 8. And when you get a whole number like that, you actually want to do the math with a plus sign and then do it with a minus sign. So if you start with a plus sign, do them separately, in other words. So you get negative 7 plus 9 divided by negative 8. And then for your other solution, you're going to get negative 7 minus 9 divided by negative 8. And just simplify each one. So in the first case, negative 7 plus 9 would be a positive 2. And divided by negative 8, that reduces down to negative 1/4. So that would be one of your solutions. And then in the other case, you have negative 7 minus 9, so that would be negative 16 divided by negative 8, which would be a positive 2. And that would be your other solution. Now, if you have a quadratic equation that has fractions in it, like this example, you have two choices. You can either go through the quadratic formula using the a, b, and the c, using those fractions as those numbers, which can be a little complicated because you're substituting in a lot of fractions into the quadratic formula. Or probably your better option is to get rid of the fractions. And the way you can get rid of the fractions is, first of all, find a common denominator between all of them. So you have 8, 4, and 4. So the common denominator would be 8. And then just rewrite them all so they have 8. So in the second one, the first fraction already has an 8, so you wouldn't have to do anything. In the second fraction, you'd have to multiply the 4 by 2. So you'd have to multiply the 3 by 2 as well. So you really multiply the top and the bottom by 2 there. And then the same thing with this third one. The 4 has to get multiplied by 2 to give you the 8. So you have to multiply the numerator by that same number. So multiply that by 2 in the top and bottom. And then, of course, 0. This is really just 0 over 1. And if you want to have an 8 in the bottom there, you'd have to multiply by 8. But 8 times 0 is still going to be 0 in the numerator. So when you rewrote this with a common denominator, you'd have 5/8 x squared plus 6/8 x minus 2/8 equals 0/8. And at that point, you can multiply both sides of the equation by 8, which is effectively just going to wipe out all the 8's. And you'll just have 5x squared plus 6x minus 2 equals 0. Then you could just determine your a, b, and c from there. So a would be 5, b would be 6, c would be negative 2. And you'd continue on plugging those into the quadratic formula. I'm not going to finish this one all the way out, but I just wanted to show you how to handle the fractions there. So if you had a problem that had some fractions in it, you'd probably want to get rid of the fractions by rewriting the equation without the fractions, and then determine the a, b, and c, and continue on working with the quadratic formula. Now, sometimes you're going to be asked to find approximate solutions. Especially if you're doing an application problem, you're usually going to want to get decimal answers. So you actually plug them into your calculator and work them out to get final decimals. Here's an example. Let's say we had 3.98 y squared minus 2.17 y equals 3.68. So our first step, of course, would be to rewrite that with a 0 on this right side. So we'll have to subtract 3.68 from both sides. So that would give us, let's see, 3.98 y squared minus 2.17y minus 3.68 equals 0. Okay, now that we have the 0 on the right side of the equation, we could determine our a, our b, and our c. So a would be 3.98, and b would be negative 2.17, and c would be negative 3.68. So then we'll substitute all this into the quadratic formula. So we'll get y equals negative b. Now b is already negative. So here's a case where we want to take the opposite of b. So that would be positive 2.17. So 2.17 plus or minus the square root of b squared. So that would be negative 2.17. Make sure you put that negative number in parentheses when you square it on your calculator. Otherwise, you'll get the wrong answer. Minus 4 times a, which is 3.98, times c, which is negative 3.68. And that whole thing is going to be over 2 times a. So 2 times 3.98. Okay, and then we'd get our calculator to figure out some of these decimals. So we're going to get y equals 2.17 plus or minus the square root of, and then when I put all of that into my calculator, okay, this whole entire thing, I put it in and worked it out, it came out to be 63.2945. So 63.2945. And then that whole thing is being divided by 2 times 3.98. And when I put that into my calculator, I got 7.96. So at this point, since we're looking for approximate solutions, we want to break this up into the two separate solutions. If you use the plus sign for one and the minus sign for the other. So I'm going to put arrows here because we're going to have two different solutions. On the one hand, we're going to have 2.7 or 2.17 plus the square root of 63.2945 divided by 7.96. Okay, and we can put that all into our calculator to get an answer, which I'll do in just a minute. And then we're going to also have 2.17 minus the square root of 63.2945 all divided by 7.96. So we're going to enter both of these into our calculator separately to get the two answers. I'll start with the one on the top. So when I put the one on the top, this one here, into my calculator and work it out, it comes out to be y equals 1.272. I'm rounding that off a little bit. There's actually more digits to it than that, but we'll round it off to 1.272 since we're looking for an approximate solution. And now let's do the one that's on the bottom here using the minus sign. And when I work that one out, I get negative 0.727. I'm going to round it off to. So negative 0.727. And those would be your two approximate solutions. Now, sometimes when you use the quadratic formula, you can end up with a negative number underneath this square root. And when that happens, your solutions are going to involve imaginary numbers. And you'll just want to write them in terms of I when that happens. So let's try this example. Let's say we have negative x squared plus 4x equals 7. So of course the first step would be to get 0 on the right side. So we'll subtract 7 from both sides. So negative x squared plus 4x minus 7 equals 0. Then we'll determine our a, b, and c. So a would be negative 1, b is 4, and c is negative 7. And then we'll plug those into the quadratic formula. So x would be negative 4 plus or minus the square root of b squared, that's 4 squared, minus 4 times negative 1 times negative 7. And that whole thing is over 2 times negative 1. So now if we simplify this down, we have negative 4 plus or minus. Now what do we have under the square root here? We have 4 squared, that's 16. And as far as the signs, we have a negative 4 times a negative 1, that's a positive 4, times a negative 7. So that's back to a negative now. So it's going to be minus 28. So we have 16 minus 28 under the square root. And then that's all over negative 2. So continuing to simplify that down, under the square root we get negative 12. Now that's a square root of a negative number. So that right there is an imaginary number. When that happens, we want to write that in terms of I. So we could write negative 12 as negative 1 times 4 times 3. So it would be the square root of negative 1 times the square root of 4 times the square root of 3, which would be 2I root 3. So that could be written as x equals negative 4 plus or minus 2I times the square root of 3 over negative 2. And as I said before, you can do this three-way reduction. So divide all those by 2, and you would have x equals negative 2 plus or minus I root 3 over negative 1. And when you divide something by negative 1, it just changes its sign. So you could break this up and do them both separately. You could take negative 2 divided by negative 1, and then plus or minus I root 3 over negative 1. And that would give you a positive 2. Now, since you already have a plus or a minus here, it isn't going to matter if you change the sign of that. So you'd still just have plus or minus I root 3. The minus would become a plus and the plus would become a minus, but you'd still end up with plus or minus in your final answer. Okay, and so those solutions are complex numbers, and they involve the imaginary number because of the square root of a negative number. Now, the expression b squared minus 4ac is called the discriminant. Okay, and the reason for that is, notice that's exactly the expression that's under the square root in the quadratic formula. And if that's a positive number, okay, greater than 0 means positive, then there's going to be two real number solutions. One when you add that number and one when you subtract it, because there's always a plus or a minus in front of that square root. If that comes out to equal 0, then there's only going to be one real number solution, because you're going to be adding 0 and then subtracting 0, and that gives you the same answer both ways. And then if b squared minus 4ac is negative, meaning less than 0, then there's going to be two imaginary solutions. And that's what happened in our last example, where we had a square root of a negative number. So depending on what that expression is, b squared minus 4ac under the square root, it's going to determine the number and the type of solutions you end up with. Now I'd like to take just a minute to summarize some of the things we've gone over in this chapter. We've looked at various different ways of solving quadratic equations. We've looked at the factoring method, solving using the square root property, completing the square, and now the quadratic formula. So we really have 4 different strategies for solving a quadratic equation, and it's important to know when to use which one. And so let's just discuss this. The factoring technique is usually the first thing you want to look for. And what you'll do is you'll get a 0 on one side of the equation, and if the left side of the equation factors, then you should probably do it that way. Factor it down and then set each factor equal to 0 and solve them separately. As far as the square root property, if the equation has the form x squared equals a number, or x plus some number in parentheses squared equals a number, then that's the perfect time to use the square root property to solve it. As far as completing the square, you would use that when the directions ask you to, because you probably wouldn't choose to do it that way, because you can always use the quadratic formula, which gives you the end result of completing the square instead. But if the directions asked you to complete the square, just to show that you know how to do that procedure, then of course you should follow the directions. But otherwise, you would use the quadratic formula. And so you'll use the quadratic formula anytime that these top two methods can't be used. So in other words, if it doesn't factor, or if it doesn't fit the form of a square root type problem. So let's just look at a couple quick examples. So here I have 3 different quadratic equations. Let's just look at each one and decide what method we'd use. Now in this first one, of course the first step would be to get a 0 on one side, so we'd subtract 15 from both sides. So that would give us x squared minus 2x minus 15 equals 0. And then the question is, can we factor that trinomial, x squared minus 2x minus 15? If we can, we'd finish this with the factoring method. And if we can't, we'd use the quadratic formula. In this case, it does factor, it factors into x minus 5 times x plus 3. And so you go ahead and do it that way, and then you set each separate part equal to 0 and solve them separately. So you would end up with x equals 5 and x equals negative 3 for your two solutions. Now you could have used the quadratic formula on this problem, but most people would prefer to factor it because it's a little shorter when possible, and only use the quadratic formula when it doesn't factor. Now in this next example, notice you have something in parentheses that's squared. So this is the perfect time to use the square root method, the second one in this chart. You would divide both sides by 3 to start with to get the squared quantity by itself. So you'd have w minus 2 squared equals 2. And then you take the square root on both sides. So w minus 2 equals the positive and negative square root of 2. And then you'd add 2 to both sides. So w equals 2 plus or minus the square root of 2. So that would be the square root method. And that works well because of the form that this original problem is in. You have something in parentheses that's squared. In this last case, we already have a 0 on the right side of the equation. So it's all going to come down to, can we factor this left side or not? If you can factor it, then you should do it like we did this first example over here. Factor it and set each part equal to 0. But if not, you'd use the quadratic formula. And in this case, it doesn't factor. So you would use the quadratic formula on that one. So you'd write down your A and your B and your C and substitute those numbers into the quadratic formula. So you'd have t equals 5 plus or minus the square root of negative 5 squared minus 4 times 2 times 6 all over 2 times 2. And you'd work that all the way out. I'm not going to finish this problem here, but you might notice that when you figure out the discriminant, this number that's underneath the square root here, negative 5 squared is going to be 25. And then you're going to subtract from that. 4 times 2 is 8 times 6 is 48. And so that's going to be a negative number underneath that square root. So you are going to end up with imaginary numbers in your solution here. And you would use the quadratic formula to finish working this out, and you'd write those in terms of I and simplify it down. So I hope that helps to kind of classify which types of problems you would use which method on. As I said, you usually want to try the factoring method first. If it doesn't factor, use the quadratic formula, unless it happens to be in one of these forms where the square root method would work well on it.